To the cloud.
This meeting is being recorded.
Hide meeting controls. Cool. All right, I'm going to do this in PDF today because I'm too lazy to sign into Google, although I had to for other reasons. Turn off the lights that are closest. All right. Good morning. Tuesday. How was everybody's weekend? Okay. Okay. All right. Cool. Well, today we're going to talk about geocoding, and it's going to be very brief, and then you guys can catch up on anything that's left, or start this week's lab, which is a quick lab too. So I might be able to squeeze chapter 9 in this week. We'll see. So to recap what we talked about last week, cartography is both an art and a science. Maps are fundamental to all GIS projects. The map is your final product usually. In modern advances make it very easy to produce good or bad maps. Maps can lie. Then new technology and the internet has changed the content and techniques of GIS-based cartography. For example, there's things like crowdsourcing now. But on to geocoding. I apologize in advance for the slides. I stole them from someone else and they're very text heavy. So geocoding, we talked a little bit about before. It usually comes as an address, which is usually in a list. And it allows us to create a point feature for each address. So you get like the address of this building, which I have no idea where it is. You guys might know. And you can, in either ArcGIS or we'll do later Google Earth, you can convert that address to a point. I'm sure you do it every single day in whatever mapping technology you use for directions. But since an address is merely a text string containing the information, you need a mechanism to calculate the coordinate for the address and then display the location on the assigned coordinate. So that's actually what geocoding is. It's taking that name of the street and the number and giving it coordinates. Address mapping is a type of geocoding using a street address database created from a streets layer. I can't remember what the one in the US, there's actually a bunch of them. UMass Amherst has their own geocoding database, which like, because it's unnecessary. The US has one that works just fine. So there's two inputs. You usually have a database, that's DBF, it's a database, or a text table, like an Excel spreadsheet, with the addresses that are going to be geocoded. And you usually have a geographic reference layer, like the streets layer. You could also geocode addresses with property boundaries layer. It's much easier to find street layers for the whole world, like on OpenStreetMap or Google Maps, than it is for a property boundary layer, which you would probably have to do state by state. I know MassGIS has it. I'm not sure if the US Census data has parcel information or if those are just points, because I always join them to the parcel data. Huh. Good question. So the output is a point file where every point represents the address. It contains all the attributes from the original table. So if you had additional things like income, race, how many people live in that house, all of that stuff gets put into the point file. What else did they collect in the sense of employment? Things like that. So how are they matched? Well, it'd be easier if there was a graphic on this, like this. Perfect. That like came out terrible, but okay. For address ranges, we're looking for 1060 Main Street. So it matches the street name to the street name. That's pretty easy. And then it looks for the block that is the closest 100 to the 1060. It also knows which side of the street is even and which side is odd. And then it estimates where 1060 is going to be. So for example, I'm going to do this with my address, but I'm going to stop recording first because I don't want that information out there. Sorry, Meg. Oh, well, you'll be able to see me do it, but I lost meeting controls. All right, I guess I will record it and then maybe cut it out later. So it works really well for my address, and that's why I'm using it. So it's going to interpolate where it thinks my address is. Oh, all right. So it's correct. If you did it on Waze or any other GPS, it puts me down here, which is insane. Clearly, that's not where my house is. So Waze always says it's going to take like 5 extra minutes to get to my house, but my house is here. And it's an issue with interpolation. I don't know why, but it does that. All right, so let me go back one slide. Now we can talk about how the addresses are matched. So usually each street segment will have numbers. So it'll tell, like ArcMap or Google Earth will know, for example, in the other one, which block is the 1000 to 1100 block. And then each segment will have attributes, which will have the even side and the odd side. So the computer will know exactly which block that it's looking for the address, and then it will find the range, and it will interpolate the position of the address point. Okay, cool. So the most common, this is, I'm actually halfway through, okay. The most common geocoding styles are streets with zone, which is like a zip code or a city, and then Street Map USA, which is it's like a standardized format. Good morning. So when you geocode things, like I just said, it's only as good as your reference data. So like my house, apparently the reference data is not very good. So if your streets layer is accurate only to 200 meters, so will be a geocoded point speed. It just clicked why it thinks my house is down the other end. So if you saw on the map, it thinks I'm on Pine Terrace. Some maps actually show that as part of Memorial Street, because there used to be like factories and stuff down at the end of that, and they were on Memorial Street. So I think Waze thinks that's part of Memorial Street, and that's why it puts my house way down at the end. I have edited Google Maps so that it knows that is a separate street. Waze is not caught up, even though they're now owned by the same company. So you can go. Say it louder.
It's still like sometimes when my dad uses Waze, it says that they're like cash toll booths.
That's funny.
I don't think it's like updated.
No, it's not. Because cash toll booths aren't a thing anymore. That's really, really funny. So you can edit Google Maps. I'm not sure how you would edit Waze things, but if you, for example, click on a place you know, you can suggest an edit and change name, remove it, say that it's closed. So for my street, the one-way actually changed directions at one point. So I went in and I said, hey, the street changed directions. You need to fix it. You can also do it. So for highway stretches. So this knows it's the block where I clicked between 1414 and 1450. And then you can report a problem. You can add a missing place. If you have a business, you can add a business. It's a great way to drive people to your company. So yes, you can update things. More error examples. So if your streets are consistently 100 meters to the north, then your points will be the same too. Sometimes things don't match up, and there are examples in the next slide of images for that. And also some road layers may have better attributes than others. There are dirt roads in my town that are still listed as actual streets. They're not streets anymore. They're totally unmaintained dirt roads. I think like the Army Corps of Engineers takes care of them. So if you don't update your maps, then you're going to have either old attributes or not good enough. So here's an example of an error. My Rhode Island accent just came out. Okay, so this is the same address list with two different street layers, and you can notice that there's 100 meters between the street layers, that it wasn't georeferenced, right? So then the geocoding attempt is just slightly off. Similarly, on this next one, yeah, that's real bad, right? Honestly, a blind person could have done better. So one of these reference layers is newer. I think it's the red one. Yep, the red one's newer, and the streets obviously have changed completely in this town. Yeah, so when you try to place houses, when you try to geocode an address, it's going to be totally messed up if you use an old layer. Like, if you're trying to geocode things over here, it would just throw an error that it can't find that address, that road. And then this is another example of an error where it'll put the address in the wrong street segment. So not only is it shifted because someone didn't do a great job geocoding, but also it probably didn't have attributes underneath. This looks like an old rural road, so it didn't know which block was the thousands block or the hundreds block. As you can see here, older rural roads, long roads, it's very imprecise. It's a lot harder to put an address on roads out in the country. It relies more on interpolation. Urban roads are smaller and they're more precise because they know, if you think of Boston and how in between every intersection there's only like 3 or 4 buildings it could possibly be. So this is an example of Los Angeles properties and hazard zones and property values. So they use geocoding to put in a bunch of addresses and see how it relates to, so the pink is very high hazard zones, how it relates to hazards. And they have information in there in the back end about property values. So they could have done a graph that showed property values in hazard zones and property values outside of hazard zones. And you could compare how they relate. They didn't make that graph on this slide, so I stole these slides from someone. But that would be the next step, is to look at like a scatter plot and try to group hazard and not hazard. It's actually a pretty cool one. So what are your questions about geocoding?